We all learn in school that our planet has this incredibly hot molten core. But what if the reason why it's so hot isn't what we thought? What if the textbook explanation is just plain wrong? Today, we're diving into a really fascinating and kind of radical challenge to the story of what's going on deep, deep beneath our feet.
Yeah, the source material we're digging into today asks that exact question. It basically starts by poking holes in the theory we all know, and then it offers up a completely new answer. So you're going to want to stick around as we unpack the problems and explore a very different way of thinking about our planet.
So, let's just quickly recap the official story, right? The one we all learn. It's basically a three-part deal. You've got a molten iron core, you've got some heat bubbling away from the slow radioactive decay of elements, and then there's the big one, all that leftover heat from when the planet first formed, like 4.5 billion years ago. That's the standard model in a nutshell.
Okay, but the author of our source material argues that this standard model is, and I'm quoting here, a floater. An idea that kind of stays afloat, but, well, it's got some serious holes in it. It suggests the official story isn't the whole story. And the problems? They start with our planet's magnetic field. So here's the first big wrench in the works. That magnetic field, the one the standard model says is generated by a dynamo in the core, it's doing something really weird. It's getting weaker. And it's getting weaker fast, like 10 times faster than it should if the dynamo just switched off. So something else has to be going on. And listen, this isn't just some fringe theory. This observation comes straight from a paper by NASA's own Jet Propulsion Laboratory. They're the ones calling it an anti-dynamo, basically saying it's actively destroying the field, not creating it. That is a huge, huge puzzle for the standard model. And that leads to this massive logical problem. We know from the geologic record that the Earth's magnetic field flips its polarity every now and then. But if the field is generated by the core spinning, how on earth could that happen? I mean, can you just imagine the planet's entire massive core just stopping and then spinning up the other way? The source material says there's just no physics we know of that allows for that. So the magnetic field is one big question mark. But the second, and maybe even bigger problem, is the heat itself. The source we're looking at points to this fundamental paradox. When you look at just how incredibly hot the Earth is, and then you look at how incredibly old it is, the numbers just don't add up. Just to put it in perspective for you, the core is estimated to be around 11,000 degrees Fahrenheit. That is hotter than the surface of the sun. It's a truly mind-boggling amount of heat. Now hold that incredible temperature in your mind and set it against this number, 4.5 billion years. That's how old our planet is. That is an almost incomprehensibly long time for anything to cool down. And this, right here, is the heart of the paradox. The standard theory says a huge chunk of that 11,000 degree heat is just left over from when the planet formed. But seriously, think about it. After 4.5 billion years, how could that much original heat still be trapped in there? Over that kind of timescale, rock is actually a pretty lousy insulator. The planet really should be a whole lot cooler by now. So just to try and make the math work, the source author did a little calculation. And it turns out, for this much heat to still be left over, Earth would have needed a starting temperature of over 110,000 degrees Fahrenheit. I mean, that's just an impossibly, ridiculously high number. And that's where you get a direct contradiction. See, our best understanding is that planets form by slow accretion, basically dust and rock gently clumping together over millions of years. A slow, gradual process like that just can't trap that kind of insane heat. It would have radiated away in the space as the planet was being built. Okay, so let's just take a breath. The author's critique is basically the magnetic field is acting weird, and the heat math just doesn't seem to work. So if it's not leftover heat, and if radioactive decay can't account for all of it, then what in the world is powering our planet's core? The source proposes a very stark, very simple, and very radical one-word answer: charge. The whole idea here is that the Earth's heat isn't some fading echo from the past. It's the result of an active, ongoing process, one that's driven by the fundamental physics of charge itself. So what even is this charge field? Well, the theory goes like this. There's a field of photons that's constantly rising up from the Earth. And here's the absolute key. To our instruments, these photons look and act exactly like infrared radiation. In other words, we detect them and just call it heat. So in this model, heat isn't a byproduct of something else. The heat
is the field?
So let's just lay it all out side by side. On one hand, you have the standard model using leftover heat and decay. But that leaves us with these nagging problems, right? The decaying magnetic field and the heat paradox. On the other hand, this alternative charge field theory says heat is constantly being generated. That would neatly solve the heat paradox, and, the author argues, it could also explain the strange behavior of the magnetic field.
Now, this is a really bold claim, and we gotta point that out. The author doesn't just toss this out as a fun idea. They state in the paper that they can actually prove it mathematically, that they can derive the total heat of the entire Earth in just a few simple steps, all starting from the basic properties of this fundamental charge. So, in the end, it all comes down to this one really cool question. Is that fire deep inside our planet just a fading ghost of a violent birth billions of years ago? Or is it something more alive, a constant invisible force that's actively powering our world this very second? Whatever the real answer is, this whole debate just shows that even the most basic questions about our own planet still hold some pretty profound mysteries. Makes you think, right? Thanks for digging into this with me.